Hello everyone, I'm Scott Milburn, Master Trainer at Aquatherm. Today we're going to learn the process of butt fusion. Before we start, we need to prepare all of our machines. Plug in your heat plate first, so you give it time to heat up while you take care of other tasks for the butt fusion process. Get your carriage hooked up to the HPU. Verify that it's working correctly. If there's any maintenance that you have to do, refer to the guidelines provided by the tool manufacturer. Gather the tools and accessories you'll need for the butt fusion process. You'll need an infrared thermometer, 91% isopropyl alcohol, and some lint-free cloths for this process. Additionally, tape measures and deburring tools and other tools can come in handy during the butt fusion process. Lastly, select the correct inserts for the pipe size that you're using. Butt fusion machines can typically fuse a range of sizes, and they'll use inserts in the jaws to adjust to those different diameters. Once your machine and tools are prepped, we'll need to cut the pipe. For butt fusion, we need to make sure that we cut the pipe a little bit longer than we need to account for the material that's lost during planing and heating. Generally, it's good practice to add an inch of length to your target length to account for these losses. Lots of cutting methods can be used, right? We have manual cutting methods and power cutting methods. You can use ratchet cutters, tube cutters, reciprocating saws, band saws, and there's other methods available as well. Whatever cutting method you use, it's important to make sure that you're not damaging the pipe when you cut it. So after you cut, make sure you inspect it, make sure there's no cracks or stress whitening or other damage to the pipe. We don't want to fuse damaged pipe into our system because that could lead to problems in the future. Now that we have our pipe cut, we're going to make sure to clean it before we place it in the machine. It's important to remove any mud or dirt or contaminants from the pipe. That way that'll help us with our alignment and to make sure that we get good fusion results when we're all done with this. These pipes are pretty clean, so we're going to place them into the machine. So now we're on to the next step of the phase, which is our clamping and aligning stage. We're going to open up our carriage and we're going to place the pipe inside. When you're tightening the clamps down, we want to make sure to tighten these clamps simultaneously. Generally, you want about an inch of material sticking out beyond the jaws, as you can see here. But really what you need to make sure is that there's enough material sticking out beyond those jaws and there's enough room to put our planer in to continue with the process. So now that we have the two pieces of pipe in the machine, we're going to move on to our planing step. Many people ask, what's the right pressure to plane at? The simple answer is that you want to plane at the minimum pressure required to actually cut the pipe. So what I typically do is I place the planer in here, I'll turn it on and I'll close the machine, and I'll gradually increase the pressure until I see that planer begin to cut the two ends. And once I see that planer cutting, then I know what pressure I need and I don't need to increase it any further. The other piece that we need to look for during the planing process is how much material we're taking off. To know when we've planed sufficiently, we're looking for continuous ribbons on both sides of this planer. So when you first start planing, you'll get short pieces coming off because the two sides aren't parallel to the planer and you're getting an interrupted cut. As that planer continues to plane, those two pipe ends will get more and more parallel to the planer, and eventually you'll get a continuous cut where these ribbons they keep forming continuously and they don't interrupt. So once you get these three ribbons on both sides of that cut, you know you've planed sufficiently. After you finish that planing, you're going to bring the two pipe ends together and you're going to double check their alignment. If you make any adjustments to the alignment here, we need to replane. So my strategy typically is put the planer in the machine, I'll plane, but I'll stop before I reach my target measurement. I'll check my alignment, make any adjustments as necessary, and then if I did make adjustments, I bring that planer back in and then I'll plane to my target measurement. So let's go ahead and see how this process works. So bring our planer in. Make sure your planer locks into the machine. You can give it a quick pull just to make sure that it's locked in there. We're going to turn our planer on and make sure that when you start the planer, the carriage is all the way open and not clamped on the planer. So as you can see, when the planer first started cutting, we got these shorter ribbons coming off because we had that interrupted cut. As it continued to plane, those ribbons got longer and longer, and pretty soon we ended up with these continuous ribbons that we're looking for. And remember, we're looking for 3 continuous ribbons on both sides of that cut before we stop planing. With the 2 pipe ends together, let's go ahead and check the alignment. You can use your finger or a pen to run it across the interface there to see if there's any offset between the 2. And if there is an offset, we're going to tighten the side that's higher. In this case, this side of the machine, the pipe is sitting a little bit higher. So I'm going to go ahead and tighten this down until I bring the pipes in, until the 2 pipes match, right on the top and on the bottom. The maximum misalignment you can have here is up to 10% of the wall thickness of the pipe that you're fusing. So now with the alignment adjusted and that high-low minimized, I'm going to open up this machine and I'm going to replane these 2 pieces because I made adjustments to the alignment. So once again, lock my planer into place, turn it on. And once again, I planed until I got at least 3 ribbons of material on both sides of the planer. At this point, make sure to clean out any material from here so that none of it ends up making contact or getting deposited into that fusion after we join it together. Before we heat the pipe, we're going to clean both sides with isopropyl alcohol one last time to ensure that there's no contamination in there from us removing those ribbons or otherwise doing any alignment checks. With the 2 pipe ends cleaned, now we can move into our heating phase. The heating phase of butt fusion is a 2-step process. We have the bead up and adjustment phase, and then we have the heat soak phase. These phases are done at different pressures. So this is a good time to go to your machine and get those pressures set up. That way you're not having to adjust them on the fly while you're actually trying to heat and fuse the pipe. So there's 3 pressures that we need to know. We need to know machine pressure, we need to know drag pressure, and we need to know full fusion pressure. And these pressures are related with a simple equation. Machine pressure plus drag pressure equals full fusion pressure. Machine pressures can be found in a variety of places. You can find them in tool manufacturer apps, you can find them in the operator's manuals for the tools, you can find them in Aquatherm's Installer manual or in the Field Pro app. We're going to look up these pressures and they're going to be dependent on the outside diameter of the pipe, the SDR of the pipe, and the specific machine that we are fusing with. So next we need to find the drag pressure. Drag pressure is what we use to account for the weight of the pipe and any other forces that will resist this carriage closing. The way we find this pressure is by decreasing the pressure on the machine down to 0. We're going to go ahead and close the machine and we'll gradually increase the pressure until we see that carriage just start to move. Right there. So you can see it just moving very slowly across. Once you see the carriage begin to move, allow it to close completely and then record the pressure that you find. This is going to be our drag pressure. Now we add it to our machine pressure and we'll set the machine appropriately to our full fusion pressure. The process for finding drag pressure and setting full fusion pressure on the machine will differ from manufacturer to manufacturer. So make sure you refer to the operator's manual for the tool for the specific procedure on how to do that. Now that we have the pressures set on the machine, we need to look up the other parameters for this butt fusion. We'll need to know the adjustment bead size, we need to know the heat soak time, the changeover time, the pressure buildup time, and the cool down time. We can find all of these parameters specifically in ASTM F3722, which is the new fusion standard for polypropylene pipe. We can also find these parameters from the tool manufacturers' apps and websites and owner's manuals, as well as our installer manual and our Field Pro app. Next, we're going to check the temperature on our iron. For butt fusion, the temperature should be 410 degrees plus or minus 18 degrees. Make sure that you check the iron at multiple spots on both sides of the iron so you can ensure that there is a uniform temperature across that iron. It looks like it's pretty good. So we're going to open up our machine. We're going to set the heat plate in the machine, and then we're going to close it at full fusion pressure. So with the machine closed at full fusion pressure, we're going to begin to see our bead start to form. This is a visual process, so we're looking for that bead to reach a specific height. Once it reaches that height, we're going to decrease the pressure on the machine to drag pressure, and then we're going to start our timer for the heat soak. It's really important to reduce that pressure, otherwise all of our melt will get pushed out of the pipe wall into the bead, and then we could end up with a cold joint at the end of the fusion. So I'm looking all the way around the pipe, and it looks like my bead has reached the right height. So I'm going to reduce the pressure on the machine to drag pressure, and I'm going to start my timer. So we're nearing the end of our heat soak process. Once this timer is done, we're going to open this carriage, we're going to remove the heat plate, and we're going to close it immediately at full fusion pressure. It's important to make sure that this joint stays in the carriage under full fusion pressure for the entire cool down time of this specific size. If we remove the pipe beforehand, we could end up stressing that joint before that bond is completely formed, and then that could end up damaging the pipe or weaken it later on when it's in operation. So while this joint cools down in the machine, we can go ahead and inspect it. What we want to see for a polypropylene fusion is a uniform bead all the way around the pipe, and we want to see that it has a roughly rounded appearance. Okay? You shouldn't see two separate beads. Polypropylene beads will come together and form as a single bead. You may still see a faint line where that fusion interface is between those molten zones, but that line shouldn't descend into the bead and definitely should not be deeper than the height of the bead. So let's take a look at an example piece and kind of go through and we'll go through a few different common mistakes that can happen and what causes them. So we can see here, right, this is a properly formed fusion joint. We have this rounded appearance, uniform bead all the way around the pipe, and we can still see that faint line at that weld interface. If we move on to this next bead, right here is where we had a planing issue. A lot of this bead looks correct because we did the correct adjustment bead, we did the correct heat soak, and the correct fusion time. But as we rotate around here, what you can see is that that bead tapers off and it disappears on this side of the pipe. If you don't plane the two ends of pipe sufficiently, there could be pieces of that pipe that don't make contact with the iron and don't melt. And that's what we're seeing here. The melt is proper on both sides, but as we get around to this piece that didn't get planed, the melt never formed there. And so we have a cold joint there, and now if we pressure tested that, it would very likely have a leak. On this next piece, once again, we have a properly formed bead. It's uniform and rounded all the way around, but we didn't clean the machine properly, and one of our ribbons got pulled through and deposited into that bead. You don't ever want to see contamination or polypropylene getting put into that bead because that can be a spot where a leak could occur. So make sure you clean your machine and remove all those shavings before you do the heating process. The next one here, we can see that this bead is excessively small. And this is the result of skipping the heat soak process. So we did our bead up and we got the proper sized adjustment bead, but then instead of reducing our pressure to drag pressure and then timing that heat soak, we removed the iron and then just fused the two pieces together. This doesn't allow enough time to form a proper molten zone, and what can result here is a cold joint that could potentially leak in the future. On the other hand, we have a large bead like this. This is what happens when you don't reduce the pressure during the heat soak phase. So we do our adjustment bead at full fusion pressure, and then we started our timer, but we didn't reduce the pressure during that heat soak. So now all of our material gets pushed out of the pipe wall during that heat soak, and we're not left with enough molten zone when we actually fuse it together. And this last one here, this is what happens when we forget to change the pressure back to full fusion pressure after the heat soak. So we did a correct adjustment phase, we did a correct heat soak, but then these two pieces got fused at drag pressure. So now what we can see is the bead is almost the right size. We can see that the bead is not rounded, and then we have this very defined line between the two because those two ends did not actually fuse together properly. So now that we've completed the cool down on this joint, we can remove it from the machine. So we're first going to reduce the pressure on our machine to 0. We're going to loosen the clamps, and we're going to remove this piece. When you remove the pipe from the machine, make sure to do a final inspection of that joint, verify that that butt fusion joint has the correct characteristics, and as we can see here, that bead looks properly formed. So this was a correctly done butt fusion. At this point, this piece is ready to be pressure tested or put into operation, and we finished the butt fusion process. So let's do a quick review. Remember, step 1 of butt fusion is get all of your tools and accessories prepped. Step 2 is we're going to prep and clean the pipe. So remember to remove any dirt, mud, or other contaminants, and be sure to cut your pipe a little bit long to account for the material that you're going to lose during the planing and heating processes. Step 3 is the clamp and alignment stage. So we'll place the pipe in the machine and get it properly secured for the next steps. Step 4 is our planing process. Remember to place the planer in the machine, look for 3 complete ribbons to form, make any alignment adjustments as necessary, and if there were adjustments to your alignment, make sure to plane a second time. Step 5 is our bead up phase. Remember, we bring the two pieces together under full fusion pressure against the iron, and we look for our adjustment bead to form. Step 6 is our heat soak. Once we have that adjustment bead the right size, we reduce our pressure to drag pressure, and then we time that heat soak and make sure that we put the proper amount of heat into the two pieces. And our last step is to fuse it. We open the carriage, remove the iron, and then we bring the two pieces together at full fusion pressure and allow them to cool down under that full fusion pressure for the full cool down time. I hope this review of the butt fusion process was helpful. Thanks for taking the time to watch. If you have any additional questions, feel free to reach out to your local Aquatherm representative.